Might you, out of the blue or any time, envision that the finish of our universe may be the start of the accompanying one? Maybe one that is, through and through, one of a kind equivalent to our own. Speculations of the multiverse are the same old thing to humanity or stargazing. Anyway, confirmation for this hypothesis is arising. The James Webb Space Telescope has, as of late, conveyed the principal picture of another universe. Since the earliest long stretches of recorded history, individuals have gazed toward the stars and considered the sun, the moon, and the stars. For the earliest individuals, the sun and the moon were openings above through which light came into a world that these individuals envisioned as a plate. North of many years, our species has found that we live on a ball that turns and contorts around a star, which is, besides, a piece of a truly enormous number of other stars and planets. We are a little piece of a gigantic universe and an essentially more noteworthy universe. Regardless of the truth that we have had areas of strength for around 100 years, we still have barely any familiarity with space. Specialists are continually finding extra qualities in the universe. They find answers to old questions, yet other secrets remain. As of in the relatively recent past, we didn't have any piece of information who made the universe or why. We didn't know, as of not long ago, whether the universe has an end or is ceaseless. With our best telescopes, we have so far been able to see around 13.3 billion light-years away. When we look, we are continually thinking back in time, since the light that telescopes like Hubble get has gone through time to contact us. We see the picture existing independently from the wide range of other things. At the point when the light started its journey to us, this assessment of the past is interesting. As such, specialists had the opportunity to review nearly to the commencement of the universe, or so they thought, until James Webb, the new space telescope from NASA, the Canadian Space Agency, and the European Space Organization (ESA), began its operation in the summer of 2022. Even the first picture from the telescope gave delicate material that touched off heated conversations among researchers. To be exact, there are 6 universes that should have existed toward the start of humanity, for which there is no glaring reason. Systems like Glass Z13 existed 250 to 350 million years after the Big Bang, and that is theoretically mind-boggling. At this particular moment, there should have been some stars constantly coming together to form whole universes, and 2 or 3 billion years would be essential. What does this mean? Is the hypothesis of the Big Bang wrong? Or is there a completely different explanation? Without a doubt, there is one. We could be checking one more universe out here. The picture of the framework group Max J0647+75 uncovers a shocking perspective on an assortment of frameworks, like significant pearls shining in the boundlessness of space. What genuinely excites researchers about this picture isn't simply its excellence, but the facts. The same region of the universe was already imaged 10 years prior by the Hubble Space Telescope. Anyway, the quality of the picture wasn't very as important, and specifically, the old and tanned objects in the background couldn't be decoded. It was just certain that they existed, and that was odd enough. The gravitational lensing effect, where small and far-off objects behind the scenes are enhanced by objects in front, let specialists know that these far-off signs of light were old and very old. Without a doubt, James Webb then uncovered dazzling new subtleties, thanks to the triple lensing effect. The universe is so old, so bright, and so profoundly coordinated that our Milky Way appears fairly common in comparison. Today, specialists are especially bewildered by the information on brightness. If the understandings are correct, these universes have produced many more stars than our universe. All the rules of cosmology might be imperfect. Maybe researchers have built all cosmological models around a presumption that is now clearly deceptive. This is a shock for those who had faith in the presence of a singular universe and anticipated that everything inside this universe could be explained with the principles of Einstein's theory of relativity. In the meantime, different parts of physics have long suggested that it's altogether more conceivable for us to live in a universe that is only one of many, with different additional aspects or universes that could exist close by or, indeed, even within our own reality. These frameworks could challenge our current ideas, as they belong to an entirely different universe and exist within a totally different time structure. One of the newly discovered frameworks was Glass Z12. Universes are generally named after the observation structures through which they are tracked down. Glass alludes to gravitational lensing, exact redshift measurement, and Z12 shows the value of the redshift. Each observation group uses a fairly different naming scheme. The redshift value of a newfound universe isn't mandatory. Universes can also get clear mathematical tasks to lay individual items. Z12 may sound unremarkable, but cosmologists hold their breath with this assignment. This value means the system existed 300 to 400 million years after the Big Bang, so it's without a doubt old. According to current cosmological theories, this is apparently incomprehensible. The discovery of glass Z12 was already celebrated as a sensation in the academic community, but significantly more ancient and fascinating cosmic systems followed. The universe and Comer CRS 93316 appears to top all the irregularities. This article is so old that it existed only 250 million years after the Big Bang. Anyway, this item shows another characteristic. Measurements of redshift yielded two exceptionally rare results. At one point, the item showed a redshift of 16.7 Z, indicating extreme age. Then, measurements of neighboring items to CRS 93316 were taken, and based on those, the universe showed a totally different redshift. The universe seemed to exist in two places and two times simultaneously. Researchers vigorously allude to the system as Schrödinger's universe, motivated by the famous quantum physicist Erwin Schrödinger, who showed that, at the quantum level, more than one reality can exist at the same time. According to these speculations, it's not just imaginable to have two universes, but there could be potentially an infinite number more, in different and endless forms. Researchers are grappling with these measurement results and acknowledge the possibility, though some may still want to put stock in an estimation mistake or even question whether these points of light are universes at all. While the spectroscopy appraisal to confirm the redshift is still ongoing, further data analysis from James Webb's IR camera system has already totally ruled out the possibility of it being a young star or an inconspicuous active galactic center. We should consider that the discovery of CRS 93316 was just the beginning of what is possible. NASA has suggested that the James Webb Space Telescope could possibly detect universes with a redshift greater than 20. These cosmic systems would have existed only 200 million years after the Big Bang, or maybe the telescope is looking much further into portions of our universe, which could attest that we have experienced a limit of existence unrelated to the Big Bang. At this point, we can no longer talk about the start of humanity, the universe, or the time after the Big Bang. Rather, we change the wording and refer to it as the edge of the perceptible universe. There lies another captivating source of light that shows an incredibly high redshift value in our pictures. This shows that universe 2744Y1 is, without a doubt, a galaxy whose light has traveled more than 13 billion years to contact us. A group of analysts has joined the best telescopes in the world, the Spitzer Telescope, Tundra, and Hubble, to capture a new image of this exceptional system by gathering data from various frequencies of light and combining them into one picture. Not only is the age and distance of this system enchanting, but the rate of star formation outperforms anything previously believed to be possible in physics. Despite being a few times younger than our Milky Way galaxy, universe 2744Y1 produces stars at a rate that is several times faster than that of the Milky Way, which is strange for a galaxy in a youthful universe. The observable universe now has a radius of 46.1 billion light-years. Beyond that, there is apparently much more. The better our advancements become, the further and more detailed our observations can reach. James Webb is theoretically able to look back 13.6 billion years. If the Big Bang happened 13.8 billion years ago, there would eventually be a limit to our observations because 200 or 300 years after the Big Bang, the universe would have been completely dark. The first stars are believed to have formed only after 380,000 years. If astronomers continue to find much older galaxies, it will undoubtedly show that all previous cosmological assumptions were wrong. At present, researchers at NASA are gaining early insights with the new telescope, which have already been amazing. Anyway, we know that time generally brings new insights, and in a few years, analysts could indeed extract even more from the telescope's capabilities. Maybe we could finally see what, in fact, occurred at the alleged start of time. Although the hypothesis of the Big Bang seemed possible for a time, there was no proof to support its accuracy. With the rise of quantum physics, it became far more likely that our universe is an unimaginably diverse and potentially complex place. Models of the bubble universe or pocket universe suggest that our universe is enclosed in a massive bubble and shares space with a myriad of different bubbles of varying sizes. The pocket universe places that within a universe, there are different parts where similar but also different conditions might exist. These pockets could give access to various aspects or corners of the universe where different rules apply. There is also a huge amount of evidence and clues for these speculations, as there are for the Big Bang hypothesis. The theories of the Big Bang and the rules of Einstein's physics were established well before the theories of quantum physics. In the future, the integration of these models could lead to a deeper understanding of our universe and the multiverse. If this turns out to be true, then we may be living in a bubble universe surrounded by different bubbles, or there could be an infinite number of universes, each with its own set of physical laws. This would suggest a level of complexity that goes far beyond our current understanding of the universe and our place within it. As we continue to investigate and uncover new data, the possibility of finding alternative universes and perspectives becomes increasingly plausible, potentially reshaping our understanding. We may interpret reality itself in a new light. Diving deeper into the implications of these new galactic discoveries, we need to explore the broader questions they raise about our universe and our place within it. Maybe one of the fundamental questions is whether the universe we observe exists, or whether our observations only reveal a much larger and more complex structure. The plausibility of a multiverse, that different potentially enormous universes exist beyond our own, has gained some momentum in both theoretical physics and cosmology. If the new discoveries made by the James Webb Space Telescope suggest the presence of universes that challenge current understanding, it could show that our universe is merely one piece of a much more magnificent, boundless tapestry. The multiverse hypothesis itself comes in various forms, each with different implications for how we might interpret reality. One is the inflationary multiverse theory, which suggests that during the early moments of the Big Bang, different regions of space expanded at various rates. This uneven expansion may have led to the creation of distinct bubble universes, each with its own set of physical laws and constants. If this theory holds, the universe we see may be just one bubble in an immense, different foam. Another fascinating idea is the possibility of a cyclic universe. This hypothesis suggests that the universe goes through an immortal cycle of creation, expansion, contraction, and rebirth. According to this model, the universe as we know it may be the result of a past universe imploding in on itself and then reappearing in a Big Bang-like event. This cycle might even repeat forever, offering one way to suggest that our universe cycles through an infinite series of astronomical resurrections. The discovery of incredibly old galaxies like Glass Z12 and CRS 93316 poses huge challenges to our current understanding of astronomical evolution. These discoveries suggest that there would have been processes happening in the early universe that we don't yet fully understand. If universes could form and organize themselves so rapidly after the Big Bang, it suggests that our models of cosmic evolution and structure formation may require significant adjustments. This revelation could lead to new theories about how galaxies and other cosmic structures form and interact over time. Furthermore, the possibility of encountering phenomena that appear to contradict standard models of physics opens the door for a reassessment of fundamental principles. For example, the presence of universes with properties that challenge how we might interpret dark matter, dark energy, and the behavior of light might eventually require an update of the standard model of particle physics. This could also prompt a reevaluation of Einstein's theory of relativity and how it applies on the grandest scales. As we continue to push the limits of our observational abilities, the role of future space missions and advanced telescopes will be crucial. Instruments that are even more powerful than the James Webb Space Telescope will be needed to probe further into the universe and possibly detect even more distant or faint objects. These advances will help refine our understanding of the universe's history and structure and may provide further insights into the true nature of the universe. Moreover, the philosophical and existential ramifications of these discoveries are significant. If our universe is part of a multiverse, or if there are domains beyond our current observational limits, it challenges our very understanding of existence. This could affect not only scientific theories but also our philosophical and spiritual perspectives on life, consciousness, and the nature of reality. As we unravel more about the universe, we could find ourselves re-examining major questions about the meaning and purpose of our reality. In summary, the new insights gained from the James Webb Space Telescope and other advanced observational instruments are expanding our knowledge of the universe in ways we had not expected. These discoveries are not just adding new pieces to the cosmic puzzle, but are fundamentally reshaping our understanding of the universe. As we continue to explore and learn, we stand on the edge of potentially earth-shattering revelations that could alter our view of reality itself. The journey to grasping the true essence of the universe is far from finished, and each new discovery brings us one step closer to unraveling the mysteries of existence.